Good day, everyone. Good morning. Time to talk about Substrate. I was just getting some links ready for myself. Actually, I always forget to do this. Hello, what's up, Mark? Thank you for joining us from the Netherlands. I've never been before. I'd like to go one day. Yeah, before I get too deep into this is Substrate Seminar. This is an online weekly collaborative learning conference where we talk about Substrate, the framework for building blockchains from Parity Technologies. My name is Dan Forbes, and I am a developer advocate with Parity Technologies. And I wear a very shiny hat that everyone likes to comment on. So I was just getting ready with some links and stuff to share with you guys before we get into the topic today. On Thursday, right around the same time as today, but on Thursday, which is Thanksgiving here in the United States. Happy Thanksgiving week, everyone. One of our rockstar developers, one of our true rockstar developers, Pierre Krieger, is going to present on some work he's been doing on something called Substrate Lite, which is something I'm really very excited to learn more about. I'm really jazzed to tune into this instance of Parity and Friends. Here's the GitHub repo for Substrate Lite. So basically, Pierre is one of our greatest Rust developers here at Parity Technologies. He works a lot on the libp2p networking stack, or has in the past, and he created Substrate Lite, which is another implementation of a client for substrate-based chains. Yes, it is Tamaka. That's correct. Pierre Tamaka, or Pierre Krieger, as he's known IRL. His government name. Substrate Lite is a re-implementation of a client for substrate-based chains like Polkadot or Kusama. So it's not using the regular Substrate code base that we all know and love. It's a totally different code base that implements the same interfaces as the Substrate code base, but does it in a way that's much simpler, so easier to understand. And the way that it does this is, let's see, there's two ways. It doesn't use native runtimes, so no executor, and it doesn't allow you to select consensus mechanisms. But Pierre's going to talk all about that on Thursday. Obviously, I'm really excited about it. So that's Parity and Friends on Thursday. Don't miss that. The other thing that is coming up, if you're a nerd like me and obviously love talking about all of this kind of stuff, there is a developer academy coming up for Substrate developers, like a certificate program, a boot camp. It's being led by Brian Chen, who is another rockstar developer in our ecosystem. He works for Akala and Laminar. He's like their CTO. Hey, great question, Core Value. I will go ahead and answer that in a second. If you have any questions like that, can you please use the Ask a Question box down there? Yes, but Robert's got the answer. We are a Rust shop through and through. Brian Chen, who works for the Akala and Laminar Foundation's CTO, great Rust programmer, makes a lot of contributions to the core Substrate code base in addition to everything he builds at Akala and Laminar. He is also creating a course to help all of you learn about Substrate. So that is coming up, and I have shared the link for that. It starts on Monday, I believe. It looks like a great opportunity. Parity is supporting it. It not only includes the course itself, which I think is like 8 lectures over 6 weeks, a capstone project, all of this kind of stuff. But there's also going to be a career fair, or like a job fair, and a opportunity to do an internship as part of that course. So it's a really, really great opportunity. If you've been looking for the chance to learn more about Substrate and really dive in, strongly recommend you check out the Developer Academy. And then last but certainly not least, we have Polkadot Decoded coming up, which this is our big community conference. We had our developer conference, Sub-Zero, in October, and this is the community conference for the Polkadot community. So if you're interested in learning more about the companies that are building on our technologies or how we support them, definitely make sure to check out Polkadot Decoded. I'm looking forward to being there for sure. So that is all of my housekeeping. Oh, and just as one more little tidbit, did you know that we have an events page? I sometimes forget about that, but that's a good place to find out about these things. Okay, so let's see. I see I already have a question. I love it. What's up? Sup, Mang? How's it going? I'm doing pretty good. It's early here, but you know, I'm talking about Substrate. It always wakes me up, gets me happy. Thank you for the great question. Yes, the link for the Developer Academy is right here, but I'll share. Thank you very much, Laurent. I appreciate that. Yes, all right, we got a good team in here. Thank you, Tomas. Yes, that is the right one, the Industry Connect Developer Academy. Let's see what else we got. I love this question. What is the difference between frame and substrate? This really is a great segue into the discussion today. As I was making my coffee in the morning and thinking about, you know, how am I going to present this to you guys? This was a big thing that came up. So let's talk about this for a second. Substrate is a framework for building blockchains. So if we're going to use an analogy, let's say that Substrate is like a toolkit for building a computer. And you can run any kind of operating system on a computer. You could run different flavors of Linux, you could run Windows, whatever. And so if we're going to continue with this analogy, just like you can run different operating systems on your computer, and that's kind of like, it's the primary way that you interface with all the components and the hardware and the machinery of that computer is through the operating system. You can run different types of runtimes on a substrate-based chain. You can use different frameworks and different paradigms and idioms to write that runtime. Essentially, as long as it implements a few key interfaces and compiles to WASM, you got yourself a substrate runtime. Frame is the way that we write runtimes for Substrate. So Frame is the framework for the runtime aggregation of modularized entities. A bit of a backronym, but it also kind of makes sense. So it's a framework, just like Substrate. It's a framework for building a software project, and in particular, Substrate, yeah, it's a kind of a base layer. It's a framework for building blockchains. Blockchains have a runtime. It is the most important part of the blockchain, from my point of view, is the runtime. And so Substrate can be thought of, any blockchain can be thought of as a type of base layer for the runtime. If you think of a blockchain as a mechanism that allows a trustless, decentralized network of participants to come to consensus on the state of a system as it evolves over time, that's my working definition for what a blockchain is. That really key part, the state of a system, I mean, there's a lot to unpack in that whole definition I just laid out there, but really what you can kind of key into is that state of a system. That's what the network exists to come to consensus on. That's the engine that makes the whole blockchain make sense, and that is the runtime. So every blockchain is a type of base layer for this runtime, this state machine. And recently, give me 1 second here, I think recently I did a somewhat good job of explaining this all with my buddy Peter Haymond when we presented for Berkeley. So I'm going to put a comment under your question, Robert, so you can check out that crowdcast as well as in the troll box there. So in this one, I get a little bit, well, maybe a lot deeper into kind of like all the components of a substrate chain and the architecture and how they interact with one another. And there's a pretty lengthy discussion. You got it, Sasha. I love it. There's a pretty lengthy discussion about what a runtime is. So I think check that out for like the real big discussion about this. But you're definitely on the right track. The Runtime is to the blockchain as the operating system is to the computer. Just like we're a rush shop at Parity, we're a frame shop when it comes to writing runtimes. There is other ways to write runtimes, and I'm pulling one up right now. There's a project called LimeChain that's making a framework for writing runtimes in assembly script, which is a variant of TypeScript that compiles down to WASM. And so they are in that language implementing these interfaces that Substrate defines. And because they're writing in a language that compiles down to WASM, they can just drop that in as a runtime for their Substrate-based chain. And actually, since we're kind of like looking at code, I'll go ahead and start spreading the news. Let's see. This is the code base that we're going to be talking about today. And let's take a look at something in particular. We are going to go, well, here, let me share my screen since we're doing the code walkthrough thing. All right, you can see my screen. So let's go back to, this is the link that I shared, the code that we're going to be talking about. Look at that. I've done this enough times. I remember to do that on my own now. What a miracle. So here we are in this repository. Let's go into the node folder, and we're going to go check out the chain spec. And let's go down here and see that when we configure the initial storage state for our frame modules. So this is interesting. This is clearly specific to frame. This is interacting with the frame interfaces to configure the initial storage state. However, what you can see is one element of the storage state is the WASM binary. And so although we are using specifically frame interfaces here, when you are starting any substrate-based chain, there are mechanisms that you can use to just insert the WASM binary of your runtime. And that is the runtime that the chain will use. When we work off of the node template, there's all kinds of stuff in here that helps do the WASM compilation. There's all kinds of like tooling that does that for you. So in particular, you can go and look in the runtime folder and look in the build, and you can see that this is where we're building the WASM. So this is how frame WASM gets built. So this is a bit of a digression here. Substrate uses runtimes that implement the key interfaces. And let me show you where you can learn about those interfaces. As with everything, it usually starts at substrate.dev. And we're going to go to the knowledge base, and we're going to go to the runtime, and we're going to go to the runtime primitives. And if you check out these core primitives, these are the things that LimeChain is implementing. And as long as they implement this in the right way and it compiles down to WASM, they're good. And so I wonder how Pierre is doing this in Substrate Lite. I wonder if he's using Frame or if he's writing his runtime a different way. It will be very interesting to see that. So I hope that helps you understand what Frame is. So now I am going to stop answering that question. So Frame is a Rust framework for writing blockchain runtimes. We just talked a little bit about exactly what that means and why it needs to be Rust, because Rust compiles to WASM. And just like your operating system creates certain ideas in your head that don't exist in other operating systems. Like, let's think of one of those. Would you ever go on your Windows machine and look for the Finder? No, it just doesn't exist. There is not such a thing. There are things on Mac machines that that exist, ideas that exist on a Mac machine that that just don't exist on Windows, and vice versa. So the operating system, sometimes you'll hear me use this term idiom, which is, kind of a weird word, which basically means like a way of thinking about something. Or the other term that you'll hear me use, what I wanted to define, is a primitive. That's if you see up in the title of the tab here, the frame origin primitive. So what's a primitive? A primitive is almost like one layer below a data type. So like if you think about on like in a programming language, like the primitive types, like the number types and everything, kind of like these fundamental concepts that you just kind of like the atoms that form the programming language. That's what a primitive is. So let's take this one step further. You think about like a hash map or something. That's not a primitive. That's like a construct that exists within the language. Many primitives have been added together to create such a construct. But if you have a list that's full of unsigned integers, that unsigned integer is a primitive. That it can't be divided down anymore. It's fundamentally part of the language, part of the framework. And so you could say that in Mac OS, the Finder is a type of primitive. It's like a core fundamental feature that can't be reduced anymore. And so today we're going to talk about a primitive that exists in the framework for writing Substrate runtimes. I'm actually going to stop sharing my screen so it's a little more human. So yeah, we're going to talk about a really important primitive in the framework for writing runtimes. And it is the primitive that we use to identify the source of information or requests in runtime. This is a concept that we need to define. Who is making this request? Where is it coming from? And why do we need to define that concept? We need to define that concept because we may want to allow certain origins, certain people, certain sources to do certain things, and not allow other individuals, people, sources, origins to do other things. And so that involves primarily one capability, the ability to unambiguously identify the source of a call or whatever. And then you want to be able to perform some logic on that, like some access control logic. Is this entity allowed access to this thing once you've securely identified them? And in Frame, those capabilities are provided by what's called the origin primitive. It is the idea that Frame uses to express where a request into the runtime is coming from. And so there are three origins that Frame defines. There is the root origin, there is the signed origin, and there is the none origin. And all of this is talked about in that repo that I shared earlier, and also, throughout the Substrate developer hub and everything. But let's talk about these a little bit. So the root origin is like the Frame runtime systems concept of the super user. If you've ever used a Linux computer and you've done like sudo so that you can impersonate the super user, if your user has those privileges, and you sort of impersonate that other account, and from that account maybe update your operating system or install new packages or something like that. But the super user account on a Linux operating system, it's like a system defined account. It's not an account that a person creates. It's an account that's created by the system itself. And then there are certain administrative features, capabilities that are only accessible by that origin. The the framework is written that way. The framework is written to expect that that origin exists because the framework creates it. And then it only allows that origin to do certain things. And so, of course, what that means is you need ways to be able to impersonate that privileged system origin. That is actually not what we're going to be talking about today. But if you want to learn a little bit more about how to do that, check out the Upgrade a Chain tutorial. So that is a little bit about the root origin. This is the administrator of the frame runtime system, the super user of the operating system, the runtime. Then you have the signed origin. The signed origin represents an off-chain user, essentially, making a request into the runtime. So this person has some account, some on-chain account that they control the private key for. And so the frame runtime system defines some mechanisms and encodings or whatever that you can use to sign a message with this private key, send it into the runtime, and the runtime can then kind of like unpack that and say, okay, this dispatch, the origin for this dispatch is this account that I know about because of cryptography. And so I can unambiguously identify the origin of this call, and now I can do things like charge fees to that user. I can charge their account for those fees because I know their account number and everything. So that is the signed origin. That's probably what you're most familiar with when you make like, transactions and stuff like that. And then the very last one, which we're not really going to talk about, I'm not even really going to start talking about it because I'm worried that I'll confuse myself. It's called the none origin. And that's an advanced origin that you'll need to worry about when you're working above the runtime, maybe, or implementing complex types of logic that you want to bypass the runtime mechanisms for accounting for resources, because the none origin, you don't know where it's coming from. So you don't know if you should trust it. You don't know who to charge for it. So you have to be really careful with it. And we're really not going to talk about it today. But if you want to learn more, check out the I'm Online palette. Send you the link to that. So the I'm Online palette makes use of this. And I think also maybe the timestamp palette does too. So these are palettes that allow like block authors to insert data kind of into blocks, which this requires the none origin. So that's about all I'm going to say about that today. But if you want to learn more about the none origin, start checking those out and come join us in Substrate Technical. Okay, so let's jump into a demo, I guess. Yeah, let's do a demo. I'm going to show you a little bit about, I'm going to walk through the code that I wrote in here. Let me share my screen. I'm not sharing my screen. Okay. Anyone have any questions or anything? Now's a great time for questions. So I'm going to be going through, I'm going to run this node and go through this. You can see it's called the Dumbo node. The last week we did the Caliente chain for the hot wallet. And so I felt like, oh man, I need to like match myself. I have to come up with a clever name for this. And so one of the most canonical evocative uses of the origin primitive, actually the thing that allows you, or one of the things that allows you to impersonate the root user, is this Pseudo Palette. And so I just was kind of playing with the name Pseudo, and I thought Dumbo was fun. So we're going to talk a little bit about elephants now. If you're not familiar, Dumbo is a American Disney character, an elephant who can fly with his big ears. So yeah, definitely learn more about the Pseudo Palette. And honestly, in some ways, what we're doing today is kind of re-implementing the Dumbo palette, but in a really, really silly, hopefully fun way. Okay, so I'm on the right branch. So let's go ahead and start up this chain. Okay, and so now, oops, not that one. Now I'm going to connect to this chain in Apps UI. And one thing, so actually, do we have any? Yes, we do. Oh, great, we have questions. All right, let me stop. Let's see what the questions are. What are native run? Yes, excellent question, Robert. So let's see. There is something called an executor. I'm just trying to figure out the best way to do this. There is something called an executor that makes this decision. So another type of idiom that the frame runtime system defines is the idea of a runtime version. The frame runtime system defines a specific shape of the runtime version and all of the things that it needs to define. And that may be one of the core primitives. I don't know what you would have to go look at, but there's some idea of a version of a runtime. And within a substrate chain, there is something called an executor, which when to the runtime is received, it will evaluate whether or not the native runtime is as up to date as the WASM runtime. And if it is, it will prefer the native runtime because it may be as much of a 10x performance increase, although the WASM interpreters are getting better and this is changing. So Substrate Lite, for instance, it does not have this executor. It only uses the WASM runtime. And it's really important to remember that when you're talking about Substrate, native runtimes are always an optimization detail. What defines Substrate, what defines, I really think Polkadot in some ways, and the idea of an upgradable runtime, upgradable blockchain is a WASM runtime. It's what makes Substrate. So the fact that sometimes native runtimes are used is an optimization detail. Really, the time when it comes into play is when you're syncing a chain. If you want to start up a new node and you know that you have the latest, greatest runtime, everything's good, you can, exactly, Eddie, it helps you go a little bit faster. You can run this node with a special flag that says, I always want you to use the compiled native runtime, and then you can sync the chain a lot faster if that's what you need to do. But when you're thinking day-to-day, running a blockchain node, Substrate node, it's a WASM runtime. That is what is used to determine the logic. That is the canonical definition of the state machine. I hope that helps. What's the difference between different origins and different account addresses? Excellent question. There are the three different default origins that I talked about: root, signed, and none. You can also define custom origins, which we're going to talk about today. So different account addresses are always going to manifest as a variant of the signed origin type. So the signed origin type, oh, what's up? I see that's you, Sasha. How's it going? The signed origin type, it has inside of it, the root and the none don't have anything inside of them. But origins can have additional data inside of them. And one origin that does this is the signed origin, and it has the account ID of the person who made that call. So an account address identifies an on-chain user. It is like the handle for that user and their account and whatnot. An origin, and in particular, the signed origin, it represents a request into the runtime from one of those users that was signed by their private key. So it's okay, I think I understand more of the question now. So origin allows you to identify the source of a request into the runtime. One source of that request that the runtime system allows is for someone who controls the private key of an on-chain account to sign some data and bundle it up, and then the runtime can receive that and say, okay, this is a signed origin and it corresponds with this account ID, this address, I know this entity on chain, and I can charge their account from it. So the origin is like the on-chain identity, the account is like the on-chain identity, and the origin represents a request from that entity. I hope that helps. These are kind of subtle, so if that doesn't help, ask again. What are some different uses of the signed origin? E.g. proxies, are these subtypes of origins? Good question. Short answer, I don't really know. I don't know. Proxies are not subtypes of origins. Proxies make use of a feature of another frame primitive, which is good, Sasha, I'm glad that helped, which is the call primitive or the dispatch primitive. And so it would be the dispatch primitive or dispatchable primitive, which the idea of a dispatchable thing primitive is that it represents a call, a type of request into the runtime system that we can take that call and receive it from one entity and then proxy it from another entity. So when we talk or dispatch it, to proxy the dispatch from another entity. So when we talk about the pseudo palette, the pseudo palette is a type of proxy. It receives a request from some user that was signed by their private key. It can then check, okay, is this the right person who actually has access to these capabilities? And if so, it takes the call, and we're going to demonstrate this in a second, and it dispatches it. It proxies the dispatch from that user. So proxies don't so much use the signed origin per se. They more use of the dispatchable call and the ability to proxy a dispatch. And then what the signed origin gives you on top of that is the ability to evaluate whether or not an on-chain account has the privilege, the authorization to perform that proxied dispatch. I hope that's helpful. Subtle things here. Again, please ask follow-ups if I'm not getting it. Let's see. These are great questions, guys. So does it mean that Frame has one interface but many implementations? If so, what is the purpose of having many implementations? What is the difference between the implementations? Performance? Great question. All right, Tom, I can try to get back to that. Try to ask it in a, help me understand where the pieces aren't connecting, and I'll do my best to answer the question. Or if there's anyone in the troll box who wants to try to help do a better job than me, I invite you, please. I can definitely use the help, but I'm going to try to dig into Thomas's question right now. So I would say that Frame implements an interface, and there is only one implementation of Frame. We maintain that implementation as part of the Substrate code base. There are many implementations of Substrate runtime frameworks. The other one being the line chain one that I showed you. So there is one interface for a Substrate runtime. Frame is one implementation that implements that interface. There are others, like the line chain one. But I don't think it really makes sense to think of having different implementations of a framework, which is kind of what you're asking. Frame is a framework. At the time that you like re-implement something, it's a new framework now. It may use the same interfaces, but if it's a different implementation, it's a different framework, I would say, probably. And what's the purpose of having different implementations, different frameworks, or whatever? It just, some people like to work in Rust. In particular, the Parity engineers really like to work in Rust. So they have written the framework that they use, and they've created all types of idioms that they make use of, like the origin primitive and dispatchable calls and all of these things that exist at the frame layer. And to understand more about the frame primitives and the things that you can only make use of at the frame layer, check out this link that I'm sharing right now. So just like there are core primitives, there are frame primitives. So if you want to use those primitives, you have to use frame. Maybe you don't like writing in Rust, and maybe there are other primitives that you want to make use of. Maybe you're a Mac guy instead of a Linux guy. Then you can use the assembly script one that LimeChain is maintaining. And so that just kind of speaks to the flexibility of Substrate, that this is all possible, and it's really a general framework for writing all types of different blockchains. And to kind of get to your last question, some may be more performant than others. Definitely, that could be a real thing too. Python, please. Ooh, I'll leave that to someone else. I'm not a Python guy. Hope that helped your question there, Thomas. Okay, let's see. Oh, this is a good question. Usually, how many runtimes running in a chain? Only one. There can be only one runtime to rule them all in a blockchain. It is the source of truth. So certainly in a Substrate blockchain, it is the runtime that's stored in the runtime. That is the magic of Substrate-based chains. So just like you may ask yourself, like, well, how many different balances does this account have? It only has one balance, and the blockchain exists to come to consensus around what the balance of that account is. Similarly, there can be only one runtime, and in a Substrate-based chain, the blockchain comes to consensus on what the definition of that runtime is. So good question, and I hope that helps. Okay, let me check out Tom's question here. How would I recognize either an origin or verify? This is exactly what we're going to be talking about today. Let's dig into the code, and hopefully this will make it a little bit more straightforward. And if it's still not straightforward, ask again, and we'll dig into this, because these are not they're not simple concepts. They're subtle, weird ones that sometimes you kind of just have to see to understand. Okay, so I am running my node. It's been running for a while here. I can see that it's finalizing blocks. It's running in development mode, so I have no peers, running all by itself, but still doing the finalization thing. Looking good. Now let's go. Oh, one thing that I'm going to have to do. I remember what I was going to show you. In order to take the node template and turn it into something new, I used a little script that I wrote in this repository DevHub utils, and it like changes the name of the runtime and the palette and the node and everything. So if we go and look at the Dumbo palette or the Dumbo node, and we check out the commits here, you can see that on the initial commit, one of the things that I did is I changed like the name of everything. And so it's no longer the node template, it's Dumbo. And so the Polkadot.js apps UI, it depends on like the name of the node to be able to load up certain types and everything. We're not going to get super into this, but in order to use the Dumbo node, you have to include these types because Polkadot.js apps UI doesn't know to do this for you. I should have added a types.json to the repository. My bad on that. So this is already here. So Polkadot.js apps UI is good to go. So let's kind of poke around a little bit. Okay, so you can see that there is this account Dumbo here. And how did I create this account? We did this by I used the subkey binary, which ships with Substrate or is part of the Substrate repo. And this helps you generate like keys and stuff. So I wanted to create some idea of a privileged user. So I used the subkey tool to create this Dumbo account, and I previously added it to Polkadot.js apps UI. So now Polkadot.js apps UI knows about this account, and I can make transactions from it. But you will notice that it doesn't have any currency to make transactions. So let's go ahead and load it up with a little money. We'll give Dumbo some money. Okay. There we go. That looks good. Okay. So this is Polkadot.js apps UI running attached to the chain, the Dumbo chain that I just launched. It knows about this special Dumbo account that I created. And let's take a look at why I needed to create that account. Let's take a look at the extrinsics that are part of this chain. In particular, I'm Dumbo. I don't know about you, but I'm really into peanuts. So Dumbo wants peanuts. But Alice is going to try to say Dumbo wants peanuts. And we probably don't want Alice to be able to say that. And so hopefully there's some logic in the runtime that's going to prevent Alice from telling everyone that Dumbo wants peanuts. That would not be good. That would be like a breach in consensus. So let's see what happens. Sure enough, that didn't work. Alice cannot tell people that Dumbo wants peanuts. All is well with the world. So how can we let the world know that Dumbo wants peanuts? Well, let's go to the Dumbo account. And there's another palette on this chain that we're going to talk all about this. I'm just kind of demonstrating things to you right now. So we're going to go into the Dumbo palette, and we're going to proxy a call as Dumbo. And which call are we going to proxy? Well, we want those peanuts, right? So let's go ahead. So let's take a second to step back. There is the Dumbo account ID that I am using. I control the private key of Dumbo. Here is the private key of Dumbo. And so this is what I loaded into Polkadot.js apps UI. And so what I'm doing right now is I'm constructing this call that I'm going to sign as Dumbo. And so the method that I'm invoking is defined on the Dumbo module, the Dumbo palette, and the function is called proxy Dumbo, and it takes as its argument a function, another function with its own set of arguments. So what I'm saying is I want to call the proxy Dumbo call, and I want to call from it this peanut gallery function and tell people that Dumbo wants peanuts. And so what's going to happen in this proxy Dumbo call is that custom will then proxy the call from that origin, and hopefully it'll work. Let's see what happens. And then I'll show you how this all it did work. Now, let's see what happens to kind of dig into this a little bit. What if I tried to transfer money from the Dumbo origin? So what if I proxied as this special custom Dumbo origin some other call? Let's see. So let's transfer And so now you're going to see that even if I try to transfer the funds from the Dumbo account ID, we'll just do one so that I know that I have enough. So this worked. The call was proxied, but let's see if the proxy call was successful. So because I made this call as Dumbo, that happened. It said, okay, this is Dumbo. He's able to proxy this call. It allowed me to proxy the call. And then it went ahead and called the balances and tried to do this transfer. So let's see if that was successful. No, that was not successful. This is another one. This is the older one that was successful. But the transfer one was not successful. It was a bad origin. So you can see that the Dumbo origin is different than the Dumbo account ID. So this is kind of a demonstration of the types of capabilities that I'm going to show you in this node. There is the ability to define a custom origin, the Dumbo origin, so that you can define your own custom authorization logic. There's the ability to do some checks and make sure that a request meets the authentication or authorization rules that you want to set up. And then there's the ability to proxy a call. And all of this is done in a much more meaningful way in the Pseudo Palette, but the Pseudo Palette doesn't define a custom origin. So what's really kind of the secret sauce of what I did is showing you how to define a custom origin. So let's see if we have questions. Okay, no questions. That's good. So now let's look at the code a little bit. So let's start by looking at, actually, do you know what? I'm going to look at this in GitHub. I think that's easier. Okay. So we're not looking at the DevHub utils. We're going back here. Okay. So let's start by looking at the Dumbo palette. So the Dumbo palette, let's go to the dispatchables. It only has one function, this proxy Dumbo call that we use to call Dumbo wants peanuts. And so what does this do? It uses, one thing to notice is that in frame, remember that the idea of a dispatchable, this is all a frame concept. So in frame, a dispatchable function needs to have a certain signature. And in particular, the first parameter is always going to be the origin, the source of the call, and then you can do some checks against it to see, is it the signed origin, the none origin, if it's the signed origin, who made the call, etc. And then there's the parameters of the transaction, the function or whatever, and they're always going to return a dispatch result. So the very first thing that we do in our proxy Dumbo call is we make sure that it's a signed origin. And then because the signed origin has this little piece of information inside of it, the account that called it, we're going to double check who that is. And now I'll talk about this in a little bit. We have some logic that allows us to see if the account that's making the call is the account that we want to give access to as the runtime system, that we want to give access to the Dumbo origin. Just like with the Pseudo Palette, you can define an account ID that you want to give access to the root origin. The Dumbo Palette provides a mechanism by which you can define an account ID that you want to have access to the Dumbo origin. And I'll show you how that works. But for now, just kind of take it for granted that there is a mechanism that exists that allows you to take an account ID and make sure it's some well-known account ID. And as long as those things match up, what we're going to do is we're going to take the call that was passed in as the parameter to the proxy Dumbo transaction, and we're going to dispatch that from the Dumbo origin, which you can see we defined up here. It's just an enum. It's just a variant of an enum, the Dumbo origin. And there's some macro magic that helps put this all together for you. But basically what we do is we just dispatch whatever call Dumbo. Now we know it was Dumbo. Now that we're down here, whichever call Dumbo passed in, we're just going to proxy it. And as long as whatever call they're calling into is accessible by the Dumbo origin, all will be well. And we'll let them know that in this, there's a SUDID event. So my did event is a, continuing my little dad joke play on words here. We'll emit a dumdid event that shows what the result of that was, if it was successful or not successful. And we saw examples of that before when we were looking at here's our dumdid event. One of them was successful, one of them was not, and we get some details about that. So that is the proxy Dumbo call. We talked about the custom origin is an enum. Let's look into the logic for how we check if an account ID is the well-known Dumbo account. First of all, we pass in the well-known Dumbo account through the configuration trait. We'll pull back out and I'll show you the mechanics of how that happens. But for now, what you need to just accept is that Dumbo account ID is the way when we're adding this module to our runtime, this is how we tell the module, the palette, what our expected Dumbo account ID is. And so this is configured as part of the palette. And so then we create this struct that implements a trait, a Rust interface that's defined by the frame system. It's called ensure origin. And what this trait does is it defines a single function called try origin that's going to just, it's going to take some raw origin, the runtime system's idea of an origin, which is this O, and it's going to try to turn it into the origin defined in the palette. And if that happens okay, we're going to return okay. Otherwise, we throw an error. And so this is kind of wrapping up the logic that allows us to do that. And so now other palettes can use this ensure Dumbo struct and make use of the logic that it encapsulates. And in terms of like, how do we turn one origin into another origin? That is macro magic. And that's something that I talk about in the README a little bit, and I'll show you how that happens. But this is why, on the one hand, I'm kind of making this sound like simple, like, it's like these familiar concepts and everything. But there is some kind of just knowledge that you have to understand about frame. And in particular, we use these macros to help kind of basically write code for you. And there is something that we have together. It basically provides you with this logic right here that will allow the frame runtime system to try to convert its idea of an origin into your idea of an origin. So we'll show you that. But hopefully, let's kind of step back. That was a little implementation detail. Let's look again at the capabilities that this palette defines. First of all, this palette gives us the capability to define a privileged account ID. The whole idea of this palette is that it requires an account ID in order to be instantiated, and then it's going to give that account ID privileged access to this Dumbo origin. And we've talked a lot about what origins are. So hopefully that makes sense to you. So the palette allows you to configure an account ID. The palette defines a custom origin and provides some helper function, some capability to check that a runtime origin is in fact the custom origin. And then we have this function transaction, this dispatchable, that checks to see if the person making the dispatchable is Dumbo per the configuration, and if it is, then we proxy the call from that custom origin. So let's see if we have questions about that. No questions. Wow. I hope I'm with y'all. I hope you're with me. So now let's go one more out and let's look at the peanut gallery, because this is how we were consuming those capabilities. Not the peanuts, the capabilities. We weren't consuming the peanuts. You can see this is really straightforward. Just like we configured the Dumbo palette with an account ID that we consider Dumbo, because we know that the peanut gallery module contains this privileged function, Dumbo wants peanuts, that we only want accessible to Dumbo, we need to configure it with some way of checking that an origin is the Dumbo origin. So that's the configuration that we give the peanut gallery palette. And this is that struct, that helper struct that we were looking at in the Dumbo palette that tries to convert it into the runtime origin and all of that stuff. So we created that in the Dumbo palette and we pass it in as a dependency of the peanut gallery palette. And then you can see it's really straightforward. Whereas in the Dumbo palette, we checked to make sure that it was the signed origin and unpacked the account ID that comes out of that. Here, we're just checking to make sure that it's the Dumbo origin, given that little helper. And then as long as it is, we do whatever logic. Here, it's very simple. We just deposit an event. But what if it was something more powerful, like, let's say, changing the definition of the runtime? That's exactly what the pseudo account serves to do. So I hope that helps answer some of your questions, Tom. Can you let me know if that kind of made things a little bit more clear for you? And if not, what's still not clear for you? I'd love to try to, help get you over that hump, because I know these concepts are not super straightforward. So those are kind of the components. Let's go take a look at the macro magic, just really quick, how that all kind of plays out. So hopefully you guys are familiar with adding palettes to your runtime. You can see here, this is the pseudo palette. We talked a little bit about that. And here, this is where we're adding all of our custom palettes. So this is where I configure the Dumbo account ID. This is another takeaway that I learned. You cannot, let's see. You see here, we're using this parameter types macro that's like a constant type or whatever. And it's a constant type. It's just like the number 1. I kept trying to define the Dumbo account ID using parameter types, and the compiler was complaining at me, oh, you can't do this in a constant function, And finally, Sean Tabrizi, who provided a lot of help, I gave him a shout out on the README there. He was like, oh, you got to use this macro, this ORD parameter types macro, which allows you to call a non-constant function. So this is how we configure the Dumbo palette to know about the Dumbo account ID. We talked about that. Then you see that we're grabbing that ensure Dumbo struct, talked about configuring the peanut gallery palette with that. So that's how that is all happening. And then that right there is where the macro magic happens. So you can see that none of these other palettes have this origin attribute here. They have module and call and config, some of them, but none of them have the origin one. And that's because none of these other palettes define custom origin. Only the Dumbo palette does that. And so this is what provides all of that convert plumbing for you, the macro magic. So there's that. Any questions? Still 50-50. Okay, I'll take it. Better than 0, 100. And I'm glad that this is helping you, Sasha. So let's go back to some of these questions, Tom. How would I recognize either an origin or verify an origin in code? Okay, let's check that out. Let's go to the Dumbo palette. So the first thing to keep in mind is remember that an origin represents the source of a request into the runtime. That is what an origin is. To make a request into the runtime, you use a dispatchable function. That's more or less the only way to make a request into the runtime is through a dispatchable function. So in Frame, remember everything that I just said is specific to Frame. In Frame, a dispatchable function, in order to be a dispatchable function, the first parameter must be the origin. It's part of what makes a dispatchable function dispatchable. So Tom, I hope that this answers your very first question. How would you recognize an origin? You recognize an origin because it is the first parameter, and I believe that it always should be called origin to a dispatchable function. So that's how you recognize an origin. And it's kind of the only context in which an origin makes sense, a dispatch. It's the source of that dispatch. So that's how you recognize it. How do you verify it? So for the Dumbo palette, we wrote this little helper that helps you verify it. For the existing origins, like the root origin or the signed origin or the none origin, the frame system provides helpers to help you do that verification. So you can see here I'm using this ensure signed helper function. If I go up here to the top, that comes from the Frame runtime system. That's provided by Frame. And so it takes any origin, could be the root origin, could be the none origin, could be the signed origin, could be custom origin. It takes that origin and it makes sure that it is the signed origin. And then the return value of that function is the account ID that signed that dispatch. The other helper functions, like the Dumbo helper, it doesn't return anything because all that it does is check to make sure that it's Dumbo. So it doesn't return anything. So that's how you verify an origin. I wouldn't call an origin a type. An origin is a primitive, and then there are different types of origins, like the default origin defined by the frame system, which has 3 variants: root, signed, and none. That's one type of origin. And then I defined here another type of origin. So this is where like this term primitive gets like a little wishy-washy. Like you can say like an origin is a primitive type. Yeah, so that is definitely one of these like more subtler ones. Thank you, Sai, for sharing some community info. I love it. Again, dispatchable is not really a type. It's a primitive. It's the concept of a request into the runtime that can be attributed to a source. So a dispatchable, if you were going to reduce it to like a type, it is a function with a certain signature. And we can even go deeper, actually, because it's all frame. A dispatchable only exists within the frame system. So a dispatchable is a function with this signature that has a weight that's defined within the decal module macro. And so a dispatchable must have an origin. That's another thing that makes a dispatchable. So not quite a type. It's like a primitive, which is more like this idea. It can be a little squishy. Let's see. Okay, cool. I see that you got part of it. That's awesome. I like it. Okay, hopefully I showed you how they're represented in code. Origin is a primitive. Okay, cool. However you make it work in your head. You got your own runtime system up there. Okay, the question was written. Okay, no worries. Okay, of what? Okay, cool. So hopefully I got through a lot of that, Tom. Please keep the questions coming. These are really, really good questions. Awesome. Love it. Okay, so keep the questions coming. Actually, let's take a second. Like, does anyone have anything random that they want to talk about? Or like not random. I mean, maybe if you want to talk about something random. But like, does anyone have any substrate stuff they want to talk about? Are you stuck on a question? Anything like that? You just got something you're really excited about. You want to show off your project. It was okay. Do you have more questions, Tom? Definitely keep the questions coming. If you want to come on screen, I can invite you on screen and we can have a little discussion. That's always an opportunity. Let me know if you're interested in that. I can invite you on screen. Anyone. That goes for anyone. Yeah, I'm just going to take a second. Just going to drink my coffee. Just sit here and wait for you guys to ask some questions. And if you don't, I'll start talking some more about origins. Let's see. I see an up arrow, Tom, as if no webcam on this machine. Okay, no worries. I could still maybe try to bring you on as just a voice, but I can understand if you're not totally comfortable with that. But yeah, if you have more questions, let me know. Like I said, I'm just going to drink my coffee. I'm going to wait for anyone else to say something because I'm so good at being quiet. Good question. If there was a multi-sig account, no, a multi-sig account is not a custom origin. And this kind of gets into the whole idea of like, what even is an account? An account is like a number, basically, right? It's just like some number. It's like a key in a hash map, basically. So you could call it a number. It's some primitive type. It's like a number or something. And the runtime system defines mechanisms by which off-chain entities have access to that account. And in particular, the way that you have access to that account is you have ownership of some private key that through cryptography that I have abstracted away because I am not a cryptographer. I'm just a little developer advocate. But there is cryptography that very smart people, like, on the order of Pierre and Brian Chen, helped to write. And it allows, if you have control of this private key, you can sign a message, and then the runtime will say, okay, this private key corresponds with this account. I know that this all lines up, and so that's how that's going to work. A multi-sig account in Substrate is defined as like there's a deterministic algorithm that you can use to take a set of keys and a set of account IDs, and together with some threshold that specifies the number of those accounts that need to sign a message, you create a new account ID, a new number that does not have a single private key associated with it in order to trust that account wants to make some action. The number of accounts, I'm not doing a very good job of explaining this. I'm gonna share something with you. Someone in our community wrote a really good. Okay, that is a whole article that someone named Shershank wrote about multisig. Read that article, Tom, to help you understand multisig. You define the threshold when you create the multisig account. Creating a multisig account, it's basically just doing math. And so you define the threshold when you create the account. And so all this is to say is that it provides a mechanism by which many account IDs can sign a message from some new account ID. So a multisig is not an origin. A multisig would use the signed origin. because in Substrate, multisig is just another type of account. Nope, multisig is not a proxy. It's just another type of account. And is that then a custom origin? No. So you're asking really good questions, because these things are all connected in rather subtle ways, and it is important to understand the difference of them. So a multisig is a type of account that the frame runtime system defines a special type of multisig. There is a multisig palette that provides all the frame runtime multisig capabilities. So other systems may define multisigs in other ways. Right now, I'm very much talking about the frame definition of a multisig. And so it's just another account. And the only way that you can sign a message from this account is by having some threshold of some well-known set of accounts sign messages. And Shershank does a really good job of explaining how that plays out. But to answer your question, from the runtime's point of view, it's just another signed origin that belongs to this multi-sig account. Going back to your questions. So I would say the taxonomy of commonly used origins is, first you have these three default ones: root, signed, and none. And then there are some well-known ones in the frame system, like the collective palette defines some origins, but you don't need to include the collective palette in your runtime. So like, it's not a required part of the taxonomy, but if we're talking about the taxonomy of frame origins, actually, this is a really good chance for me to plug seminar next week. Sasha, who I've kind of been chatting with in the troll box and whatnot, is going to come on next week. And Sasha, if you'd like, please feel free to like drop a link to what we're going to be talking about next week. But Sasha did some really awesome work exploring Frame's governance capabilities. And that talks about some of the other important origins that may be included in a Frame runtime, but they're not part of the core taxonomy, like those three root, like the root, signed, and none origin. So let's see. And then you can define your own custom origins. So that would be a little bit about the taxonomy. We talked about the threshold. Multisig is not a proxy, it's an account, not a custom origin. A multisig account is not an instance of the signed origin, no. But if a multisig account proxies a dispatch into the runtime, that dispatch will have a signed origin. Okay, let's see some other questions. How to add EVM into a runtime. Can you please walk through the code of adding the EVM? Today, I will not be walking through that code because it is rather involved. But what I will do is share with you the Moonbeam code base. And really, anytime you have questions about the right way to use the EVM, that is where I would encourage you to check out. Yes. Actually, I'm going to send you one. Sorry, I'm just trying to find the right link here. Check out Moonbeam and see how they do things. Moonbeam also has an element channel. Joshi is around a lot, who can help with that kind of stuff. So unfortunately, I won't be really answering that question today. It's a great question, and I hope I gave you some good resources to get that question answered. Can you go through the logic of substrate consensus? Like, man, you're asking really good questions that I'm not really able to answer. I have not really explored the consensus layer much. That's another thing that my buddy Joshi, who works at Pure Stake with Moonbeam, knows a lot about and has done a lot of research into. But no, I don't know a lot about that. I've really mostly stuck to the runtime and really mostly with Frame runtimes up until now, because as you can see, there's like a lot to learn there. But let me share with you. So if you want to learn more about consensus, one place that you can start is just going to our Rust docs and just start searching different terms. So aura is a consensus term. And so just kind of start searching through that, looking at the different crates that create the different consensus systems. In a Substrate node, all the consensus stuff is up at the node layer. It's not at the runtime layer. And because the node template makes such heavy use of like the default stuff, it can be a little hard to understand where logic is coming from. But if you look at the code in the service file in the node template, you can start to see where like we're pulling in some consensus and finality related crates. And so at some point I am going to start learning about consensus. I just haven't gotten there. I'm like giving myself breathing room to really feel like I understand the runtime. But when I do want to start learning about consensus, that's going to be the first thing that I do to start, is just kind of poking around the node template, looking at how it sets up its consensus capabilities, and then just kind of diving in iteratively. Let's see. I know, what are some other good ways for you to learn more about consensus? I know that if you go check out our recipes, we have some great recipes about consensus. So I'm going to share that. This will help get you started learning a little bit more about consensus. And then I'm going to share one more. This is a little out of date, but still a good resource, I think. It's a UTXO workshop, which demonstrates implementing like a Bitcoin proof of work type consensus mechanism. So unfortunately, kind of a non-answer again, Min, but I hope I've given you some good things to go learn about. Okay, I saw they had some chat, so let's see. Yes, Philip, thank you for sharing that. That's awesome. I love, it's definitely all right to share that stuff. Substrate seminar is 100% for the community. So if there's anything that you're proud of, any work that you've been doing that's related to Substrate and you just want to share it and tell other people about it. And like I said, if you want to come on screen sometime, Philip, we can do a whole seminar about your project. I think it's awesome. And so, yeah, please absolutely feel free to share kind of stuff. Let's see. Sasha asked a question. The way I think of it, so I'm reading Sasha's comment here. The way I think of it is that origins are what live closest to the runtime, and everything that's an account or derived by one lives a little further away and relies on origins to make dispatches to the runtime. I think that's a fair enough approximation of it. The origin is like the runtime's abstraction layer on top of ideas like account. So yeah, I think that's a very good way to think about it. A very helpful bit of information to share. Yes, and I see that you're sharing your governance stuff, Sasha. I love it. Awesome. Thank you, Min. I'm glad I didn't let you down too bad. All right, I'm going to take another sip of my coffee. Okay, we got another couple minutes, so let me just see. I'll share my screen. Okay, so Min, another thing that I would do if I wanted to learn about consensus is I would go poke around the core Substrate code base. So let me just show you a little bit about what that would look like for me if I wanted to learn about consensus in particular. So I think that is at the, I'm not even sure, maybe the client layer? Let's see. It is. Consensus lives at the client layer. So, and so how did I make that decision? So client is like the, kind of like the main node. I know it's not docs. I know it's not frame because it's not runtime. Consensus isn't really a primitive. Primitives would be stuff like origin or block or dispatch, and consensus doesn't really feel like a primitive. and it's not a test, it's not util, so it was a little bit process of elimination. I was like, all right, I think it's probably client. Bin is not where you find source code of how Substrate works. So now we know how I found that. Let's go into consensus, and you can see there's all this stuff around here about consensus. And so, manual seal is one type of consensus that people like to learn about, especially for development. And so, just kind of poking around in here and, learning about things, seeing how they work, asking questions in the Substrate technical channel. What is this consensus folder inside here? I don't even know, but this is how I would start the process of really learning about consensus. The other thing, Min, is if you go to the Developer Hub, recently I made some fairly substantial overhauls to the glossary, which sounds kind of boring, but really it was unbelievably informational, educational about this. And in particular, I tried to drop lots of links about consensus. And so you can see there's lots of information about consensus here. There's links that go out to like Foundation research. Yeah. So check out the glossary on consensus as another good way to learn more about that. Okay, but let's go back to talking about origins. I want to show you if I want to learn more about, runtime stuff. Okay, so now this makes sense. We want to go into frame. And let's take a quick look at the Pseudo Palette, because that should look very familiar now that we talked about Dumbo. So one thing that the Pseudo Palette does a little bit differently is, whereas Dumbo, we configure the palette with a single immutable account ID, has access to this custom privileged origin. With the Pseudo Palette, it's actually an updatable element of storage. So you configure the palette with an account that initially has access to these privileged functions. And then if this account later, so Tom, getting to your question about multi-sig, here's something that could happen. And this is kind of along the lines of what happened on Polkadot. So Polkadot was initially launched, the Polkadot network was initially launched with the Pseudo Palette that gave one account access to the root origin to do runtime upgrades and stuff like this. One of these runtime upgrades could be changing the account that has access to the Pseudo Palette from an account ID that's controlled by a single private key to an account ID that's controlled by a multi-sig account. And that be like one of the most that you could move from a highly centralized chain, and using a lot of the things that we've talked about today, origins and dispatches and upgrades and everything, you can upgrade the chain and actually make it more decentralized by replacing the account that has access to the pseudo capabilities with the multi-sig account, which is just another account ID. And then you can see that, let's look at like pseudo. It looks very, very similar to what we did in the Dumbo palette. We checked the origin. We made sure that it's the same as that key, and then we dispatched the call. So pseudo works almost exactly like the Dumbo. The only difference is that we're dispatching as the frame system raw origin root, so that this kind of system level origin, as opposed to the custom Dumbo origin. So that is that. Okay, cool question. So I'm going to go back to frame, and now the last thing I'm going to look at is, and this is kind of like a teaser for what Sasha's going to talk about next week. So hopefully this kind of gets you excited, is that the So the collective palette defines an on-chain governance body. So the Kusama and Polkadot councils and technical collectives, they are instances of the collective palette. That's all they are. So what this on-chain governance body can do is make proposals and then vote on these proposals. And of course, a proposal may pass or fail. That's one way to define the pass-fail threshold. But you could also just say that a threshold always has some amount of votes for and some amount of votes against. Not sure if you can hear my dogs barking downstairs. I have two Great Danes. They're loud, like me. So the collective palette defines a custom origin that is a little bit more along the lines of the signed origin. It contains some extra data inside of it. Dumbo didn't contain any extra data. It was a pretty simple example. But for the collective palette, the members origin tells you how many members voted for a proposal and how many members voted against a proposal. So what is a proposal in frame? A proposal in frame is basically just a suggestion to perform a dispatch into the runtime. And so we define an origin that says this proposal is coming from the collective palette. This dispatch is coming from the collective palette by way of a proposal, and this proposal passed or failed, whatever, with this member count. And so then you can perform different types of logic. Let's say that the proposal passed with a threshold of 100%. Maybe that indicates a certain type of logic. Or maybe it passed with only 2/3%, or maybe a 50%. So you can even go deeper into the origin primitive and do more with it. Here's a type of origin that is a lot like the signed origin, but it says kind of like, okay, this account is performing this dispatch in their role as a member of this collective. So again, it's like we want to express certain concepts in the runtime, and so we use the origin primitive to help us do that. And Sasha's going to go way, way deeper into this next week. I'm excited to learn more about it, because if it sounds a little bit like I'm waving my hands, like I don't really know what I'm talking about, bingo, that's exactly what it is. And so Sasha's been learning a lot about this, and he's going to teach me all about it next week, and hopefully teach all of you about it too. I'm really excited about that. So yeah, we're getting really close to time now. I don't see any other questions coming in. Yeah, so we talked a lot about origins today. They're really important because they're what provide the frame runtime system with authentication and authorization capabilities. They're very specific to frame, which is a way of writing runtimes for substrate-based blockchains, but there are other ways of writing runtimes, and they may have their own primitives and data types and idioms and all that kind of stuff. We talked about how you can proxy calls from different origins, and that this is very important for like the Pseudo Palette and stuff like that, for stuff like on-chain governance, which we're going to learn more about next week. Don't forget, we're going to end the way that we started. It's very, feels like to end the way that we start. So on Thursday, we have Parity Friends coming up. And I'm going to open this link and get the nice link for you guys. So don't forget Parity and Friends on Thursday. Pierre is going to be talking about Substrate Lite. If you are wicked dorky like me and you want to learn, and you want to get a certificate in substrate development from the very best, please check out the Industry Connect Developer Academy. And last but not least, if you like coming and listening to people talk about Substrate, please join us at Decoded on December 3rd. That's our community conference. So thank you so much for joining and for all your great questions. Really, really great questions today, guys. I hope that I answered them all well, and I hope that you learned something. And I hope to see you next week when we're going to learn about governance together. All right. Enjoy your Tuesday. Enjoy your Thanksgiving. Bye-bye.